Assalamu alaikum. This is experiment 2, and the name of the experiment is the determination of Atterberg limit test. This is Casagrande apparatus or liquid limit device. This is grooving tool, the sample, soil sample. This is a spatula, beaker with dropper, moisture can. You can see a set of moisture cans, glass plate. This is balancing machine or weight machine by which we can get the weight of our soil sample. By which we can get the weight of each can. First of all, we have to take the cans on the balancing machine to get the weight. This is number 15. This is number 21 can. This actually the random number. This is not necessary for our experiment purposes. To determine the can for the designated number, we give 11, 20, 21 like these random numbers. And in our calculation part in the data sheet, we will find the weight of each can, which is taken from this video. So finally, we are taking all of the weights of the cans. After that, we are taking 200 gram soil. You see how we calculate 200 gram soil from our balancing machine. This 200 gram of soil is a sample soil. Finally, we get 200 gram of soil as the sample soil. This soil will mix with water. You can see how we mix the water with the soil. The amount of the water is not mandatory or is not prescribed. You can take as much as water to properly mix with the soil. You see how we mix the soil with the spatula. This is actually making a paste of soil and water, and the water is using here to increase the workability, and also the glass plate is using here to increase the workability of the mixing. This paste is very important to get the accurate result. If we are not mixing properly, we cannot get the proper result. You can see we are adding extra water. It takes time to get the proper mix of the soil water paste. Now we are taking the sample in the Casagrande machine. In the Casagrande machine, there is also a dial reading. We will see how we use the dial reading to get the number. The thickness of the soil in this machine would be uniform, and you have to careful about the thickness. You have to remove the extra soil from the top portion of the soil of the machine. you have to maintain the thickness of the grooving tool with the thickness of the soil in the device. You can see we are taking almost the same thickness of the grooving tool and the soil in the Casagrande machine or liquid limit machine. We have to maintain the thickness properly. This is the mold. We are cutting the soil at the middle of the device. And when we are dropping the machine, the portion of the two sides will tends to merge, and whenever the tendency of the merging will increases, we will finish our experiment. We will starting the blow. You can see how we give the blow to the machine. You can see how it merged. So this is the initial point for the 15 blows. Sorry, this is 16, and in the machine the number is 16. So we are taking the 16 blows for the first observation. In this experiment, we will take another 5 or 4 observations. We'll take. Now we are going to take the plastic limit, and for that plastic limit you have to take weight of the can as before. With the soil, we have to make a thread or sample or this type of roll is making to get the plastic limit. You can see how we cut the roll, and we will take this to the can. একটু পরে we can take these threads or the roll to the can. We have to take the weight, both the can and the soil. Then we will keep this to the oven. We'll keep it for the drying purposes, and it takes 24 hours to get the dry weight. And in our calculation part, we will see the weight of the dry soil, and by using these values we can get the plastic limit of the soil. Thank you. In this part, we are going to describe the calculation of the Atterberg limit of the soil. You can find there are two parts, liquid limit and the plastic limit, and there is another part. This is the starting part of the test. This is shrinkage limit, and we will not describe the shrinkage limit in this part. We'll just trying to solve or cover liquid limit and plastic limit. In the graph, you can find this is the water content, that is W, and this is the volume. And in the soil, if you mix or if you pour water, then the state turns from shrinkage limit to plastic limit and plastic limit to liquid limit. The higher amount of the water is added, the state changes to liquid state. So by using this type of graph, we can find the state of the soil, if it is liquid state or it is plastic state. These are the materials and the equipments. You can find there are two steps of experimental procedure. One is for liquid limit test and another is for the plastic limit test. In the liquid limit, in the video where we find the liquid limit, we took some cans for the weight, and those cans are designated with random numbers. So these 20, 21, 22, 23 are the random numbers. These are not related with our experiment. And for the observation 1, we take can number 20, and the weight of that can is 15.24 gram. Whenever we are pouring the soil sample or the paste in the can, then the weight is 30.52, and after the drying with the help of the oven, the weight is 26.70. So this is weight of can plus dry soil. This is weight of can plus wet soil. If we are deducing this weight with this weight, then we can find how much water we add in our paste, and the amount is 3.482 gram. And if we deduce the weight of dry soil plus can minus the weight of the can, we can find the weight of dry soil. This is 11.46 gram. The moisture content of the soil sample is getting by 3.82 divided by 11.46 into 100%, we can get 33.33. And for this experiment, for this observation, we use number of blows 19. That means 19 number blows. And by using this observation, we repeat this test to 4 or 5 times. for number of blows 19, 24, 32, 35, but not 25. And all of these values are putting in the graph. This is number of blows and this is moisture content and number of blows. You can find a graph here, and you have to draw a line of the base fitted as the base fitted line, and in that base fitted line you have to choose number of blows like 25, and for that 25 number of blows you have to find the moisture content. So in that case, for the 25 drops or 25 number of blows, the moisture content is located as 33.7%. So the liquid limit is 33.7%. In the plastic limit, the procedures are same. You have to just get the moisture content and you have to take the average moisture content, that means 13.37 and 23.32. The average is 18.3. This is the plastic limit. And finally, you have to find out the plasticity index, that means the liquid limit minus plastic limit. We found the liquid limit was 33.7% and this is plastic limit 18.3%. so if you are deducing from 33.37 to 18.3, the result is 15.4%. so this is the plasticity index. This is the end of Atterberg limit test. Thank you. Assalamu alaikum warahmatullah.